Find the empirical and molecular formulas for the compound formed when 15.5 grams of phosphorus reacts with 19.99 grams of oxygen. The actual molar mass of the compound formed is 283.88 grams per mole. So this is really two questions here. Find the empirical formula first, and then using the empirical formula and the actual molar mass of the compound, you can find the molecular formula. Without both of those pieces of information, the empirical formula and the given here molar mass, you can't find the molecular formula. Without this molar mass here, you could just find the empirical formula just from the 15.5 and the 19.99. However, we'll do both in this example. So the first three steps here will involve finding the empirical formula. The last three steps will convert that empirical formula into a molecular formula. So step one is convert grams into moles, and we'll use N equals little m, mass in grams, over big M, molar mass. So for the phosphorus, we take our 15.5 grams all over the molar mass of phosphorus. Read that off the periodic table. It's 30.97 grams per mole, and you get 0.5 moles. Oxygen, do the exact same thing. We had 19.99 grams of it divided by its molar mass. Again, read that off the periodic table. 16 grams per mole, and you get 1.25 moles. Now, the whole key to empirical formulas is knowing what the ratio between the phosphorus and the oxygen is, and we do that by looking at the moles. It's a mole ratio. So I could say that the empirical formula is 0.5 or P.50 However, there's no such thing as 0.25 oxygens or 0.5 phosphoruses, so we need to get this into a whole number, the lowest whole number ratio. So you can do that by taking your smallest number. In this case, it's 0.05, but whatever example you're doing, once you've found the moles, find the smallest number and divide everything else by it. So in this case, it's 0.5, so you should get something. The first one should always be 1 when you do that, and then do the remaining elements, no matter how many there are. In this case, there's only 2, but you divide them each by the smallest, and in this case, that's 0.5. So if I do that, I get 2.5. So now you might be tempted to say, okay, that's a better ratio, 1 to 2.5. However, again, we can't say PO 2.5. There's no such thing as that. So whenever you get something that's not a whole number, that's clearly not a whole number, had this been 1.9 or 2.1, we'd probably round that to 2 and just say it's 2. But 2.5 is right in the middle. So what you do is you want to convert these both to whole numbers, and in this case, because it's 0.5, you can multiply each by 2, and you get now the whole number ratio of 2 to 5. Note that 2 to 5 is the same as 1 to 2.5 is the same as 0.5 to 1.25. It's just this is the lowest whole number ratio that we can make out of those numbers. So that would be step 2. Step 3 is now just write the empirical formula using the lowest whole number ratio. So our empirical formula is P2O5. So if that was the end of the question, you'd be done. If it just says, what's the empirical formula for this compound when you react these two things together, you would be finished. Note we didn't use this at all yet, the actual molar mass of the compound, because that comes into play when we want to find the actual molecular formula for this compound. So note that the empirical formula being P2O5, we know that's just the lowest whole number ratio. The same ratio could be P4O10, P6O15, so on and so forth. So the real formula for this compound will be one of those. It'll keep the same ratio, but we don't know if it's actually 2 and 5. Like I said, it could be 4 to 10, 3 to 15, so on and so forth. So how we figure out what it really is we do these next steps. So step 4, or step 1 of finding the molecular formula, if you already know the empirical formula, is to figure out the molar mass of the empirical formula. So I'll call that big M with EMP as the subscript there. And we have 2 phosphoruses plus 5 oxygens. And when we add that all up, we get 141.84 grams per mole. Now note that the actual, the one that's given in the question, is not 141.84. It's bigger than that. So the real formula then cannot be P2O5, or else this number would have been the same as that number. So how do we figure out what it really is? Well, it's going to be some multiple of these numbers. As we know, if it's 2 times, it'll be 4 and 10, or if it's 3 times it, it's 6 and 15, so on and so forth. And so to figure out what number we have to multiply these 2 subscripts by to get the true formula is divide the actual molar mass, which is what I'm going to call the one that's given, by the one we just found, the empirical one, and we get 283.88 all divided by 141.84, and that works out to pretty much 2. Again, at this stage, you should always get a whole number, or else you've done something wrong. So if you get 1.99 or 2.1, again, it's going to, you'll round that to 2, but you shouldn't get, 2.7 or something like that. Lastly, then, we just take this number and multiply each subscript by it, and when I do that, I'll get my final answer. And that gives us P4O10. That is the molecular formula, or true formula, for when phosphorus and oxygen bond. The empirical formula, just the lowest whole number ratio. The molecular formula, that ratio should be preserved when you're doing these. However, it'll be the true, again, if you could actually see this compound, you would count 4 phosphoruses and 10 oxygens.